Before we start coding, now let's first review the characteristics of the underlying process that we talked about in the last video. The first is the current stock price, that is 23.44. The current stock price will be passed to the underlying process through a simple quote. The second one is T0, that is 29th of December 2011. The current date will not appear in the constructors by itself, but it will be combined with dividend rate and the day counter convention to construct the flat forward yield term structure of the dividend. For the risk-free rate, it is much like that of the dividend, so we will combine the current date of T0 and the risk-free rate and the day counter to construct a risk-free rate flat forward yield term structure. And for volatility, we will be using a constant volatility, and we will use the volatility, the current date, day counter convention, and the calendar of our choice to construct a black constant volatility term structure. So now let's go to the coding part. We will continue to use the coding from last time. First, we will review the Word file that contains all the constructors. When we learn about the constructors, we go from the top to the bottom. Like we first go to the pricing engine, that is the Analytic European engine, and then we go to the generalized Black-Scholes process. Under this process, we look at each of its parameters, for example, quote and yield term structure, to see what is needed to construct this Black-Scholes Merton process. Under quote, we have here the simple quote, and under yield term structure, we choose the flat forward. But when we start to do the coding, we will go from the bottom to the top, so we will start from the simple quote. The simple quote has only one parameter, that is the underlying stock price. So we will first define the underlying stock price, that is of a real type. And then we will construct our simple quote. So we will name it underlying price. It has only one parameter, so it is the stock price. We'll pass the stock price to the quote here. And then next step, we will have the flat forward yield term structure for the dividend rate. So it has basically three parameters that we need to define here. First is the reference date. We will define a new date of T0. And it's 29th December 2011. And the next is the rate. It's just like the real type here. We will just define it as a rate type. Next, we will construct a dividend yield term structure of flat forward. So we will have three parameters: the date, the rate, and day counter. For compounding and frequency, we will just use the default settings, so we do not need to prepare those two parameters. Okay, for date, we will use the T0 of 29th December 2011. And next is rate. As we talked about in the last video, the rate is just a real type. So the reason why we use rate is just that we want to make it clear that this is a dividend rate. And the last one is day counter. We will use the business 252. and we will name it day counter. So now we have all the parameters ready, we can start to construct our flat forward dividend yield term structure. We will name it the dividend yield term structure. And we will pass the three parameters. The first is T0, and second is dividend, and the last one is day counter. So now we have the dividend yield term structure ready. Next is the risk-free rate yield term structure. It is almost the same with the dividend rate. So we will just define our rate of risk-free rate here. I think it's 0.00602. And we will copy and paste here. So we will name it the risk-free rate yield term structure. And change this to risk-free rate. So now the last step is the constant volatility term structure. The volatility term structure has only one more parameter than the yield term structures, that is the calendar. For calendar, we will use the target calendar, that is the calendar used by an interbank system in European. So first we will define the calendar, and we will name it calendar, and we use target. We'll also define the volatility. You can see here that volatility is a type of volatility, but as we talked about in the last video, the volatility type is the same as the real type. It just have a different name so that it is more clear what kind of parameters we are using. We will name it vol, and it's 0.3287. Now let's construct the volatility term structure. We will name it the volatility term structure. And we will pass through the four parameters. Let's check the sequence. The first is date and calendar volatility and day counter. So that is T0 and the calendar, and then volatility, and then day counter. So now we have all the four parameters ready, we can start to construct our Black-Scholes Merton process. We will use the shared pointer from Boost. And we will name it BSM process. And we will pass the four parameters into the process: the underlying price, the dividend yield term structure, the risk-free rate yield term structure, and the volatility term structure. Now let's go to the pricing engine part. First, we will try the analytic engine, and later we will talk about the Monte Carlo method. and has only one parameter, that is the BSM process. So now what is left is to set the pricing engine to the analytic engine. So we will set the pricing engine of our option to the analytic engine that is already built. And before we go to the output, we need to set the pricing, the valuation date to the current date, that is T0. Now let's define the option price, that is the net present value of the option. And we will go to the output part. To save you some time, I have wrote the output codes here, and I will just copy and paste it. So now let's build our solution. And then we will run the program. So we have the core price, that is 0.902361. You can compare your result with mine, and we have also a list of arguments set here, so you can compare your output. Next video we will talk about the Monte Carlo method.